afternoon, everyone. Thank you for coming to my talk. I hope you've had a good morning this morning. So, my name's Abizer Nasir, and I'm going to talk to you about why core data is still alive and kicking. What I'm going to try and explain is core data is still relevant. There's no way I can explain all of core data in one 40-minute session, not even a day session. It's a very big framework, and there's a lot to do. So this isn't going to be a tutorial about core data. I'm hoping to give you some ideas about how to use core data and some of the issues related to it. But I'm hoping that I get you enough interest, and you can come and find me all of today and tonight to come and talk to me more about any of this stuff. So, why should you listen to what I'm saying? I'm an iOS contractor in London. In the past 7 years, I've worked on 10 large projects. 9 of those projects needed to persist data locally, apart from the ones that were just web wrappers or banking apps, which don't store data at all. Out of those, 8 of them I used core data, and 1 of them I used Realm. And whenever the choice comes up to me of I need to persist data in the application, I will always use core data. So what is core data? We have AppKit for macOS, we have UIKit for iOS, we have core location, core animation, core Bluetooth, we have all these individual applications. Core data is the system version of the system's provision of persistence for your application. When you need to save data, large bits of data, and access data, you use core data. It's what the system gives you. And something that people sort of get wrong sometimes is they think it's just about saving data to disk, and that's part of what it does, but that's not the main thing about core data. Core data is the model layer of your application. I would suggest that I use it as the model layer of my application. Some people don't like to have their core data objects in their views. I think it's fine because views need models, and it's a model. So I just pass the core data objects in. The other thing you need to think about is, although on iOS, if you persist data, by default it will use SQLite store, it's not a database. If you start doing your mapping as if it's a database with relationship tables and identifiers and, n order, fourth order, first, second order sort of optimizations, it's not going to work. It's not what it's designed to do. What you think of it as, I have these objects, and these objects are related to other objects, and that's what it is. It's a graph of the relationships of your objects in the app. What I like about it is that it comes with a system. So when you have an upgrade, as we've just had with iOS 13 and macOS 13, core data is updated to work with it. If you're using something else and you want to move straight over to the new frameworks, you don't have to wait for an update of any third-party library for it. It comes with the system. It's optimized with the system. It's just as buggy as the system sometimes, but it comes with the system. It also works with Swift, SwiftUI, and ObjectiveC. So it works with all the languages that the applications support. And it works across all the platforms. It's like foundation storage. It works on iOS, it works on AppKit, it works on the TV, I think. But it's just, actually, no, it doesn't work on the TV because you haven't got a store. But it works across the two main applications. So you can write one model, and if you're writing a multi-platform app, you just got one model. How you display the data is slightly different, but you only have one model. Unfortunately, there are some bad parts about it. It's a very large framework. There's lots of things. There's lots of moving parts in it. There's lots of configurations. Lots of things can break, and I'll get to that later on. But it is large and it's hard to understand. But like most things in the application, iOS is large and hard to understand. Everything you do is large and hard to understand. It's just another thing for you to learn. Sometimes, and this came up in conversations I was having last night with the other speakers, they say, yeah, I know core data, but I've got some people in my team who don't know how to use core data, and I'm not very good at core data, and I don't want to sort of get into it without anyone to help me if things break down. That's valid, but you don't not use parts of the system because it's hard to use or because you don't know how to do it. You go and learn it. You find out how to do things and you do it. It's like Git. You don't think, oh, well, I've got a junior in the team who's not very good at Git. I'm not going to use version control. You learn. You teach each other. You develop practices around it. So it's a valid thing, but I don't think it's a real deal breaker. Because it's so large and because it's quite old, When you start getting bugs and you start getting performance problems, they are hard to find. And I can feel this. It happens to everyone. It happens to me. Every time I use a core data project, something breaks. I will be sat there overnight drinking, trying to find out what's gone wrong, and I'll rip my app apart and I'll try and build it again. It happens to me, but I work my way out of it. Like most things, there is a solution to these things, and you just have to find it. It takes a lot of reading, but the more reading you do, the better you get at it, the more confident you get at it. And next time you think, I need to use core data, you don't think, oh, big scary core data, I'm not going to do it. So yes, they are hard to find, but they can be found. There are tools to help you find them. The other thing which I think is more valid nowadays is it's essentially Objective-C. Objective-C means mutable data objects. It means NS object subclasses, in this case NS managed object. And a lot of people who've come into the ecosystem recently, it sounds weird, but a lot of people are coming in just learning Swift and just enough Objective-C to be able to read tutorials and stuff. So if all you know is Swift, if all you know is immutable objects, things like NS object, not overriding. There's a lot of things you're not supposed to override in NS managed objects. There's the whole idea of hashing, key value observation, notifications, all these things that you get with NS object that people are just not used to using. And so it's very scary to think, everyone's telling me to use immutable objects, everyone's telling me to use structs for my data models because nothing breaks, nothing changes. But here's this persistence thing, which is objects. And yes, it is very unswifty in the sense that you pass something an object and it's a reference, so you can just change it underneath. It doesn't sort of live as a value type as a lot of people are used to, a lot of people are trying to use for their model objects. But because it's based on Objective-C, doesn't mean that it's a bad thing. One of the reasons you don't want mutation in your objects is because you don't want things to change under you. You don't want to expect something to happen and then it changes and then you're left in an indeterminate state of something. The thing about NS managed object is it's mutable, but everything that changes you can be notified of. You can watch everything that changes because of KVO, because it's because it's NS object. If something changes, you can catch it with a notification, you can catch it with KVO observations, and you can react to it. So it's not like I have an object that's changed, oh my God, what's happening? You can watch for it. It's valid because I've spent the past 4 months working on a greenfield application on iOS 13, and I've been using core data and SwiftUI and Combine. And yeah, come talk to me about it afterwards. I've had lots of fun with this. Yeah, trying to catch mutations is very difficult, especially with SwiftUI when it doesn't want to change things. It is possible. And the main reason is you've tried to use core data in the past and it's broken on you. You think, oh my God, I've had so much trouble with it, I don't want to touch it again. Again, that's valid, but really, I have problems with lots of things. That doesn't mean I never touch them again. I try, I learn. Some things I try and I think I don't like, but in general, I like core data. That could be because I've always used core data and I'm reasonably good at it, but I got that way by always using core data. So it's a case of if you have a chance and you want to learn something, it's a good thing to learn. There are alternatives to core data, and I have seen them all. I have seen large bits of application state being stored in user defaults because it's easy. Yeah, OK, when you're prototyping, you think, I'll just put it somewhere in user defaults. But really, application data in user defaults, it does not belong there. It's also seen people using small bits of data in NS coding and just JSON files on disk, which you load and unload. That's fine for small bits of data, but if you've got something like a Twitter feed, you're not going to store that in JSON. You're not going to use NS coding. It's not going to work. And I don't know if anyone here may be asking me questions about this, but every time I do a core data talk, somebody says, Realm's much better. Fair enough. There are reasons why I use core data, but it is actually a really valid option to use instead of core data, especially if you have a lot of cloud work to do. There's some really neat things that Realm lets you do with cloud synchronization. And Realm, unlike core data, is cross-platform. So if you want to have a shared data source between your Android application and your iOS application, don't even think about core data, just use Realm. You know, we're engineers. You have solutions, you have problems, you try and match the two together. If Realm works for you, it works for you. Let's go on to some of the more major stuff. So this is what most people see when they look at the core data documentation. They see this thing here and they think, oh my God, what's going on? You think, I've got this store here, I've got that, and I've got this coordinator thing in a managed object context. And a lot of the tutorials, they talk about, well, you need to set your managed object model up, and then you get the persistent store, and they all talk about all these things here. It's valid. There's only a couple of things you need to worry about, really, when you're getting started and if you just want to use it. And it's managed object model. That's how you define your objects and your relationships and the properties on those objects, and how changes to some objects affect changes to other. Persistent store is where it's kept. You can either put it on iOS, you can put it into a SQLite store, which is the default, or you can just do it in memory, which is really fast, but it takes memory. If you're on iOS, if you're on the desktop, you can put it into an XML store, you can put it into a binary store, you can write your own. You can write your own on iOS, but I wouldn't do it. But you can go crazy on these things. And persistent store coordinator, yeah, you can do some really neat things with it. I've been doing this for a long time. I mean, I've done 10 projects in 7 years, but in the 10 years I've been doing programming for this app, ecosystem, I have never done anything crazy. Yes, you can have multiple stores, so you can have one database and two databases and link them together. Never needed to do it. Yes, you can write different importers, so you can have a JSON store, just put all your stuff in JSON. I've never needed to do it. You can do it as an exercise, and I have friends of mine who have done it. You never need to do it. So all this stuff that scares you, that's not what needs to scare you. The only things you need to worry about is how you define your data, how you access your data, and how the data goes up and down. So if you're looking at it the old way, with that struct there, this is how you would set up your core data stack. All right. Not many people do it this way nowadays, but if you haven't touched core data in a while, this is what you'd be looking at. You'd be setting up your managed object model, your persistent store coordinator, wiring them all up together, and all that. Okay, Xcode will give you this as a big data dump in your application delegate when you set it up, if you set up a core data project, but yeah, you can do this. Nobody does that. Not nowadays. The modern way to do it is using an persistent container. It's a really handy thing. What it does is it just wraps everything up that you need to do for creating your stack. And what it does is it takes, you create a container with the name of it, and that sets up where it stores it on in your applications, in your documents directory. I like to pass this, you don't need to do it, I pass it in, and I'll explain why later. It's the definition of where you get the model for. This is the model file that's created for you, that you create when you define your objects. And then it loads asynchronously. If it fails, I'm lazy and I just bail out. And I set up two properties here. One, which is really handy. It means that the view context, which I'll speak to, whenever there's a change to another context, or a sibling context or a child context of the container, it will automatically push the changes through. I do it to the view context so that if I make any background saves, or if I do a network fetch, if I do a network request, I get it, I save it on the background. I don't have to worry about manually pushing it through to the main queue. It does it. It just does it for you automatically. If you've been doing core data for a while, you realize that's actually a fairly big deal. This merge policy I'll speak to you later about, but it's basically, it says when I save two versions of an object, which one do I want to, which trumps the other one. Property and trump, I had to say it, I'm sorry. The reason I put the managed object model into a separate helper variable is because of this. It's all very well having a core data store, but when you want to write your tests or when you want to write your SwiftUI previews, you need to have data objects that you need to put in. If you don't specify the model object, you'll get all these warnings in Xcode saying, you can load up a separate in-memory container. This is probably the most important bit, is the fact that I load up, I create a store with the same managed object model, the same definition of the objects, except I use an init memory store type, so I just keep everything in memory. It doesn't touch the disk, it doesn't touch the existing data from my application of the simulator, and what I do is I create the store and I populate it with objects I want to in my tests or my previews, and it runs. But having the definition of the managed object model there, I've learned that the hard way. It just stops a load of errors. You can do your tests by loading up an in-memory container. If you're using SwiftUI Previews, you can load your data in there, but as long as you've got that, you won't get a load of error messages or crashes sometimes. Because what happens is that it loads one managed object model, and then you'll load another one because your application also runs whenever you're running tests or Swift previews. And then Xcode says, why have I got why have I got two definitions of the same managed objects here? Because you can load separate managed object models into it. Again, one of those crazy things I've never had to do. It's just a hint. If you start getting the errors about I've got multiple managed object models, just use that. It's a lot easier. OK. There are people in this world who don't like to use storyboards or interface builder. I'm not one of them, but they do. And it's like, I just want to write everything in code because I can see where it is, it gets on my Git, et cetera, et cetera. That's fair enough and that's valid. I have spoken to people, other meetups, when I talk about core data, and they say they won't use core data because they don't want to use the data modeler because it's like using storyboard and interface builder. It's not true because you can write your stuff by hand. It's possible, it's long-winded, but you can do it. I just use the editor for various reasons. One, this isn't tutorial stuff. That's the data model of the application I'm working on at the moment. It's all squeezed in because I'm trying to get everything in at the same time. It's probably not optimized because I'm just trying to get it to work at the moment. But that's the sort of thing you're looking at. You're looking at multiple objects, all related to each other in various ways, or with different property types, or with different relationships, or with different one-to-one and one-to-many relationships, or double-ended. I'm not going to write that by hand. It's very hard to edit, very hard to change. You might think, I've got it all, but you'll miss things out. I mean, that's just the definition. I'm not showing you the fact that some of these things are optional or non-optional. Some of the relationships are optional or non-optional. Some of the deletion rules, which I'll show you in a minute, you have to put them in. The defaults for each one of these parameters. It's just a lot easier doing it by hand. But if you looked at tutorials and they do something like a to-do list, yeah, fine, one or two entities. That's what you end up with in real life. There's some of those are like mutable objects that we change in the application. Some of those are just network objects that come down. And if you're wondering why I've got objects that don't talk to each other, that comes from literally a day of just working through your data and where it goes. Core data isn't a silver bullet. If you have data in your app and data flows through your app, you still have to work at it. Core data lets you do it, but you still need to know what is changing where, what is changing what, where the data is coming from, what the mutation rules are. So when I suddenly get the island there of two objects that are unrelated, that comes from a lot of discussion about how these things change. And that's one of the reasons why core data is hard, because it's so large and because it's not opinionated in the same way that other frameworks for persistence are. You get to choose how you do everything, so you need to think about how you do it. And that's the weakness of core data, but it's also the power of core data. The fact that I can create any sort of structure I want for my data that works for my application. But you have to know how to create that. Sometimes you don't know what you're doing, not in terms of what core data is, but when you're writing the app, you don't know what you're doing. So you just write these big tables, and then you break them out later. And then you have to analyze them. And trust me, you think running this is bad. Trying to do the instruments on it's even worse. It's all part of it. So when you're doing modeling, so as I said, I'm just going to give you loads of tips about this. It comes from, essentially, you get an NS managed object, which is the main class that core data stores. And then you create a subclass of it, and then you write definitions for it. And you might be thinking, well, I have these two things are sort of the same, so I'll just make a superclass, and I'll have two subclasses out of it. That's fine if that's what you want, but just remember that A, you're not supposed to think of it as a database, but you sort of have to, because something that people miss is the fact that it stores it in a database. So if you have a superclass with two subclasses, the table that stores the data is as wide as everything that's in it, which may not be what you want, because then you get one big table with lots of things. Most of the time, that doesn't make a difference, but if you're writing apps with lots of data that have performance implications, you don't want that big table with everything in it. It's easier just to have two individual classes. So you'll have duplication between them, but don't worry about the duplication so much. It's not something you need to... Duplication in this isn't really that much of an issue. Most of the data is quite small. When you create relationships between objects, make sure it's double-ended. So make sure that you have a parent, not really a parent and a child, but if you have a relationship from one object to another object, that object has a relationship backwards. That does two things. One, it creates referential integrity so that when you delete one object and it has relations to other objects, you can deal with it. The other side is that there's not one entry point into your model. If you have, you can come in through one object and you can get to the other objects through it. I'll explain why that's important later, but it lets you traverse your graph without having to constantly be querying your data store on it. And you need to set your deletion rules carefully. Something else that catches people out because they don't do their deletion rules carefully, and that's where you start getting all these crazy errors coming up whenever they try and do a save. So I'm just going to do this. Again, this is from a real application. So the object itself is a basket, and it has products. And it's non-optional, because what's the point in having a basket without products? That doesn't mean that it can't be empty. An empty set is fine, but it has to have a set of basket products. And the point is, because it's non-optional, I've made it cascade, which means that when the basket is deleted, all the related objects in this, they're deleted. So when I delete the main object, everything inside it gets deleted as well. So I don't have to go through and delete each one of these, it gets deleted. The other one, I don't know why I'm pointing at it, is the opposite side, which is, so you have lots of baskets, but there's one current basket. In this case, it's optional because the basket doesn't have to be the current basket. And the deletion rule here is nullify. So if I delete the current basket, I don't delete the current basket reference because I want to keep that as it is. And the code that deletes this takes care of setting a new basket reference to a new basket for the reference. But the point is that because this is optional, I don't want to have to delete the thing that it's optional to because I don't want it to do it that way. But getting these things right and understanding your data model to that extent will save you a lot of the errors because that's where most of them come from. The other thing that Xcode will do that it never used to do is it will create your data objects for you. If there's an option in the data modeler that says just create my data in the background, it'll put it in derived data and you never have to touch it. It creates an interface for you that doesn't even get into your project, and it just runs. And it looks like this. I don't like doing it because I can't see what it's doing and it's in the background. So I generally, there is a button to say generate the class itself, which generates an empty class and it generates the extension. And you can go through and edit the class object, put your own helper functions in there, your own initializers, and this is what's generated. But I put this up here because everything comes out, that's an object, comes out as an optional. And the relationships, so this is a retailer, and it has sub-objects called buyers. It just comes out as a set. Not typed, not anything, just a set. And the address and the name, they're optional. So every time, if I'm using this and I'm getting it out, I'm having to cast the set to the right type. I'm having to conditionally unwrap the strings that come out of there. And it's just very, very wordy. And it doesn't really express my intent in my model. It also generates these helper functions, which lets you deal with sets. You hardly ever use them. Essentially, when you're creating a load of buyers, you don't add a load of buyers to them. Because of the second relationship, it's much easier creating a buyer object and just saying the relationship to the retailer is just add a relationship to the retailer. And so adding relationship on one side will set the relationship on the other, which is another reason to have dual-ended relationships. So yes, you can do it this way, but I find it annoying. It's actually quite possible that you can write your own model. The easiest thing I find to do is I actually generate the model, decide what types and names, what the variables are, make sure that it's matching up to my model, and then I just rewrite it. So in this case, that's an int. Name is a non-optional value, so I make it I actually make it non-optional. I leave that as optional, and I make my set not an NS set, not an Objective-C, not an Objective-C set, but an actual typed set, a Swift type set on that. And I write my initializer for it as well. Just makes life a lot easier writing my own initializers for it. Once I do this, which is basically a parameter-wise initializer, it's just a lot easier writing extensions on it that just use this. So I've always got a set way of doing it. So if you get a chance, always write your own models. It's not difficult. Yes, you have to keep them in train, but you get much better control over your types in it. Oops, did I get too many? Right. Better speed up now. So when you're actually looking at data, if you remember the original thing, everything lives in a managed object context. You can't really get a managed object outside of its context. And you really, there's two types of context. There's a main queue context and there's a background context. Main queue is if you have a main queue managed object context, that's what you use to drive your UI. You can pass it around your UI objects, pass it around your views, and because it's all on the UI queue, everything works fine. Background, really handy for saving. So if you're doing a fetch request, if you're doing a network fetch, you get your data, you save it on a background queue, and if you remember I had the automatically merges from parent, it goes and fetches and updates the data from there. You get data out of it by using a fetch request. It's changed to have a generic type now, but what you do is I'll just show you. It's a lot easier. So because it's typed, you create a request, and then you create a sort descriptor for it, which basically defines how it's sorted. And then you do a predicate, which is like a SQLite query, just so you say what I need it to do. So you create the request, you define the two types, you set them, and then you run them. All these things run as optionals because they have failures, and it's really handy to be able to get your failures out of it. So I have results. If I have results, it'll either go in here, or I'll either have an array or no values in it, or it'll fail. So that's how you want to fetch individual objects. If you ever need to get a particular object with a predicate, you get it that way. You really need to do that. Most of the time, what you're doing is using an fetch results controller, especially if you've got table views or collection views. You set a fetch for it, and it deals with the section names, number of titles, and everything. Again, easy if I just show you an example. So if you're used to table views and collection views, because an fetch results controller has lots of delegate methods, you can basically say, before I change it, I'll begin updates, and then an fetch results controller knows what's changing, what's been inserted, deleted, moved around, and you can do it. You can use the same sort of methods on the table view or the collection view for moving insertions and deletions, and you can finish it on an update. So you get so many different change points out of your fetch results delegate that you can use it to drive changes on table views and collection views, which is really it's what really made programming on the Mac, on the desktop, a lot easier, because you can just generate large data sets and have it load table views and collection views very easily. It works really well on iOS. And it takes care of all the memory for you as well. But what it does is, when you're doing fetch requests, it does something called fault. And when you're looking at your Xcode console, you see lots of things saying fault, 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 and you think something's wrong because it says fault. All that really means is when you do a fetch request, because of the memory thing, it says, well, I've got these objects, but lower down I have this cache where I've actually got the data in the objects, and until you actually tell me that I need the data, I'm not going to populate it for you. So you can have a list of products, a list of titles, and you say, fetch me the products with these titles, and it'll fetch just the products, and all the titles will be false until you actually say, can I have the title for this? That's good and bad. One, it's good because you're not loading everything into memory at the same time, into your view context, which is faster. It's bad because if you need all the data at the same time, you have to hit that little cache every time to get it. But that's not an issue because, again, as I said, if you're profiling your app and you see that hitting lots of faults for some things that you need a lot, you can configure your fetch request to not fetch faults, and it will actually fetch the data for you, and so you can just populate it straight away without running through all those things. Another reason that used to fall over is if you're looking say, on the main queue, and you're looking at a collection view, and then you've done a network fetch, and some of the data has changed and it's been deleted, all of a sudden you get these things falling over called I can't fulfill a fault because the object that it's talking to has gone away. It's been deleted. It was a major issue that used to happen a lot. You suddenly could not fulfill a fault and the app crashes, or you have to write all this code to deal with it. What you've had for the past couple of years is query generations. What it does is it pins the context to the last time you fetch something. So even if the object on a separate background thread has deleted itself, has been deleted. It hasn't gone because you've pinned it to a context, and it works until the next time you do a fetch or a save. And it's just as simple as writing that. You basically pin it to the current generation, and that's it. Now you can fire a fault on the objects, whatever happens, because while this query is running, it still exists. That saves you a lot of trouble as well. So that saves a whole load of broken errors. And if you do any more fetches, it saves again. Saving or resetting. Anything else that changes, merges or changes the data fetch will update it to the next generation. Something else that used to messes people around with core data is threading. I mentioned already that if you're going to pass any managed objects to your view, you need to do it on the main thread. And basically, you don't want to think, I'll try and make life easier for myself, and I'll perform a fetch in the background, and I'll pass the data up to the main queue. It doesn't work because you're passing objects that have been fetched on a background thread to a main queue thread, and the result is either no data at all or it's undefined, which is just as bad as no data at all. There's really two types of queue context. There's the main queue concurrency type, which runs on the main queue, and as long as you can pass data around that all the time. So if you have if you've got one view and another view, you can pass a managed object from that view to the subview quite easily, as long as it's on the main thread. It's quite easy because if you're using a container, you basically say container.viewContext, and that's the one that is the UI context anymore. You don't have to worry about setting the concurrency type. Private queue, they run in the background. The way containers work now, that if you're using you can ask it for a new background context, or you can say perform background task, and you have a context in the block. They take care of running in the correct thread. So if you're doing any saving, you do it within the block, and it comes out of it. But that's a safe way of doing background threading. And again, you don't have to set the private key concurrency type because there's only two methods to get them. And if you set the automatically merges changes, this will take care of pushing the changes up to your main view context. So if you're already viewing the data, you can update it if you haven't got, you've got the query generation set, so you can refresh it. Something else that people fall over on is saving. So you create these objects, and if you remember the way that I described that when you tell core data to generate these objects, everything comes back as optional except for foundation types. What it's trying to say is that you can create anything you want. So you get this core data object, you can put, you create it in the context, you give it whatever data you want, but it's not going to get validated until you save it. So all these things about this relationship is non-optional, or this property is non-optional or optional, none of them actually get checked until you try and save it, which is why I try and write my own to be more concrete about what I want my objects to look like. That's why saving is a throwing method, because if you have any validation errors, this is where you pick them up. Most of the time when I'm developing, I'm running it like this. Because I may have made a mistake in validation, or I don't understand my data, or I'm changing the data a lot, and this catches it. When it's actually in production, I either change the try to a bang, because sometimes if you can't save the data, it's a major problem, and you don't want to corrupt your user's data, so you fall over. Or you try, and if you know the sort of errors that can come up, depending on your application again. For example, if it requires a related object and it doesn't have one, you have the option of asking the user to create one or creating a default one yourself if you want to. So you have the option again. So it's one of these things where, like, why do I have to go through the trouble of doing a try catch on this? Because it's safer for you when it doesn't happen. And also, another thing that will fall over is merge policy. If you saw my container setup, I had, and it's merged by property object trump merge policy again, property and trump again. What that says is that if I have two types of data, I have data already persisted, and I'm overwriting the data from a fetch, then the data from my fetch overwrites the data in the store. There is one that goes the other way, but you hardly ever use that one. Most of the time, you want to overwrite it with new data. But if you don't set a merge policy, and you have a unique key identifier, which is the only way where this comes up from, what will happen is that the default is to error. So if you do a save and you've overwritten something and it doesn't like the fact that it's overwritten, it'll just give you an error on merge policy, NS error type, which is the default for merges. So just make sure you've set a default for saving. Okay, performance. I'm looking at that time and thinking, how am I going to come through performance? Okay. There's lots of things you can do with performance. As I said, most of the time you can just run the application and it'll work for you until you run instruments, and then you really find the bits that need to be fixed. The important things are avoid fetch requests. Every time you do a fetch request, it goes all the way down to the disk, because when you're saying get me new data, essentially you're saying I need to do a new query. So it'll go all the way down to the disk and it'll perform a query. Relatively, that's fast, but that's relatively fast. So if you say I have 100 objects and you do a fetch request for each of them, that's 100 round trips down to the disk that you don't need to do. So in that sense, what you could do is just get them all at once. You know, just do a single fetch to do it. An example of that is if you're doing a search and you're saying, you know, just give me all the products that start with AB. You might do a fetch request for all the products that start with A, and then a fetch request for all the products that start with AB. There's no point. You know, just do a fetch request for all the products that start with A, and then you've got them all. So if AB, you just filter the returned array, and then just keep filtering down until it changes the first one, and you need to fetch it again. Which it's a lot faster than doing it the other way. In the application I showed you there, I do a large network fetch to update objects, and I need to match them up against objects that I already have so I can update them. And what I do there is I just basically load everything at once. I just say, get me everything that exists, and it puts it in my managed object context. And then as I'm decoding the new data, I don't have to hit the disk every time to say, do you exist? I just check if it's there, and I can update it and then save it all at once. And that's a big performance hit. The other way of avoiding fetch requests is not to use them. You have relationships. So if you need to get objects related to something, just follow the relationship. It's a lot faster than doing a fetch request, because what it will do is it'll hit the row cache first, and if it needs to, then it will hit the disk. But at least you have the option of doing it that way. So following relationships is another reason why you think of it as a graph rather than a database, because you're not hitting it every time. Moving on swiftly. If you think about the new stuff that comes with core data, as I said, it gets updated with the system. So when there's changes to the system, core data gets updated. It's alive and kicking. So with SwiftUI, you can actually, if you use the default template, it puts the managed object context into the environment variable, or gives you an environment with a managed object context, and that's the view context. So you can do things like doing a fetch, and so you can do a fetch, and you can just load it into a list. That's fine, except for the fact that you can't really configure this. So it gives you all of it or nothing, and so it's of minimal use at the moment. You're better off actually using a view model for things like that. But it just shows you that core data is growing along with the system. It's not just some sort of stagnant thing that's never being updated. Combine. So as I said, mutable objects change. How do you watch them? Well, KVO is one way to do it, and now KVO is part of Combine, part of the system on iOS 13 and Mac 13. So basically, you can just do a publisher off it. And so this basically, I get publisher for title, sync self, title new, and that just works straight off in a view. Something I'm trying to work on, and it doesn't always work, is that they tell you to use view models for your views. Core data objects are observable objects. They're supposed to be observable objects. I still find it easy to put KVO on them, so you can pass objects around. Hopefully that'll get better in the future. It's quite buggy. Everything's buggy at the moment, but yeah, hopefully if it works, it works. Like a lot of these things, when it works really elegantly and it's beautiful. Okay, if you're not worried about SwiftUI or Combine, maybe you're interested in diffable data sources. And it's fetch result control, as I said. If you're using a collection view or a table view, you have the begin updates, do the updates, end updates. If you're using diffable data sources, you've got a different, and it's fetch results controller delegate that just returns you a diffable data source snapshot. So you can just plug that straight into your diffable data source and not have to worry about doing the matchups anymore. So, and that's just one of them. You have a diff one. So if you have a table view, just a table view, which is a list, and you want to change things around, you have something that tells you what the differences are, and you can apply that straight away. Okay. Yeah. Cool. If you imagine something like Git, Git is simple. There's like 4 object types and a couple of references. So it's really simple, but it's not easy to use. You have to know a lot of things about how to use it. Carthage, it's another one. That's where I get the whole simple, not easy about. Carthage as a dependency manager is really simple, but it's not easy to use. But it's simple. There's not a lot of moving parts to it. And it's the same thing with core data. Core data is really simple. It's an object graph. You have your editor. You can set your relationships. You set your types on it. But there is so much stuff around it that you can do that I haven't even touched upon. You know, being able to like respond to deletions, handle it. You know, do I want? You know, you can stop things from being deleted. You can create things on deletion. You can clean up your whole database at different points. You can watch for changes for everything. Core data gives you so much if you know where to look for it, and it's just. But it's really difficult to understand it. But it's worth the time, it's worth the effort. Every time you have this little error, Stack Overflow is just full of these answers. In terms of books, I quite like this one by Mark Abizer. It's a little more towards Objective-C side of things, but it's got a lot of the background data about how things work. I think for the more modern audience, this is probably the best reference to it, Objective-C, ObjectiveCIO's version of core data. They've got some lovely extensions in there that make working with core data manage objects a lot easier. The NS manage class, which helps you work with the performance side of dealing with fetch requests, etc. I think that's it. I'm going to finish there. Thank you very much for listening to me.